In this video, we are discussing Class 11 Mathematics Chapter 1 Sets Exercise 1.2 Solutions. Before going to the video, don't forget to see the introduction part of Exercise 1.2 to get the concepts and formula. The link is below in the description box for the previous videos on sets. In this exercise, the first question, which of the following are examples of the null set? First one is set of odd natural numbers divisible by 2. What are odd natural numbers? What are set of odd natural numbers? 1, 3, 5, 7. It goes on like that. In this, what is the number divisible by 2? Odd numbers are not divisible by 2. So, there is no element that satisfying this condition. So, there is no odd natural number divisible by 2. Therefore, this is a null set. Next question. Now, set of even prime numbers. What are even prime numbers? The prime numbers which are even. As you know, there is only one prime number which is even, that is 2. You can see these are the prime numbers 2, 3, 5, 7, 11, 13. It goes on like that. In that, only even number is 2. So, the even prime number is 2. Set of even prime numbers is 2. This is a singleton set. You know what is singleton set? We have discussed this in the introduction part. Singleton set is a set which is having only one element. Third one, x is such that x is a natural number, x less than 5 and x is greater than 7. See, x is less than 5 and also greater than 7 is not possible. In the number line, you can see number x less than 5 means which is less than 5. Natural number less than 5. It can be 1, 2, 3, 4 like this. But which is number less than greater than 7. Natural number greater than 7. 8, 9, 10, it can be anything. There is no number which satisfies both the conditions. Therefore, this is a null set. The next one. Y is such that Y is a point common to any two parallel lines. Two parallel lines are there. Is there any point common to those two lines? See, these two parallel lines never intersect. Common point between the two lines is the intersecting point of the two lines. When they don't intersect, there is no common point. So, parallel lines have no common points. The set is a null set. Therefore, this is a null set. Next question. So, the second question. Which of the following sets are finite or infinite? You have seen in the introduction part what is a finite set, what is an infinite set. The finite set are set having countable number of elements, whereas infinite set is having elements uncountable number of elements. First question is the set of months of a year. The set of months of a year is, you can say 12 months are there. This number is finite. So it's a finite set. Set of months in a year is a finite set because it has 12 months, which is a finite number. The next one. In this set, elements are 1, 2, 3 and it goes on like that. It is a set of natural numbers and it is an infinite set because it goes up to infinity. It is not a countable number. So this set is an infinite set because it has infinite elements of natural numbers. The next problem. It has elements 1, 2, 3 and up to 99 and 100. Clearly, the elements are limited to 100, 1 to 100. The natural numbers from 1 to 100. So, this is a finite set. This is a finite set because it has 100 elements. We will move to the next question. Here, the set of positive integers greater than 100. The elements are 101, 102, 103, and it goes on like that. So there are infinite number of elements. This is a infinite set. This is an infinite set because it has infinite elements of natural numbers greater than 100. The next one, the set of prime numbers less than 99. See, that means less than 99 means it has a limited number of elements. So this is definitely a finite set. The prime numbers can be 2, 3, 5, 7, 6, on up to 97. 97 is the last prime number in 90s. But this number of elements is limited. So the set of prime numbers less than 100 is a finite set since it has definite number of prime numbers less than 100. We'll move to the next question. Next, the third question. State whether each of the following set is finite or infinite. The set of lines which are parallel to the x-axis. This is x-axis. How many lines we can draw like this parallel to x-axis? You can keep writing, you can keep drawing lines parallel to the x-axis. These are parallel to the x-axis. This is x-axis. You can draw any number of lines parallel to the x-axis. The set of lines is infinite. So it is an infinite set. So set of lines parallel to x-axis is infinite since we can draw infinite number of lines which are parallel to x-axis. Next, the set of letters in the English alphabet. They are from A to Z. The number of letters are fixed. 26 letters are there. So it is a finite number. So this is a finite set. The set of letters in English alphabet is finite because it has 26 letters. Next one. The set of numbers which are multiples of 5. See, x is, it can be written as x belongs to n and x is equal to 5 times n. So that means in roster form it can be 5, 10, 15 and it goes on like that. It is having infinite number of elements. So this set is an infinite set. The set of numbers which are multiple of 5 is infinite since there are infinite number of multiple of 5. This is a infinite set. Next one is the set of animals living on earth. Guess what? The set of animals living on earth are finite. Though the number can be very high, but since animals on earth are finite in numbers, the number may be a huge number. This is a finite set. The next one, set of circles passing through the origin. So this is origin. How many circles can pass through this? 1, 2, 3, 4, like that. Yes, circles that can pass through a point are infinite, right? So circles passing through origin are infinite. So the number of elements of this set is infinite and so the set is infinite set. So the set of circles passing through a origin is infinite since there are infinite number of circles that can be drawn passing through a point. The next question. In the following state whether A equals to B or not. You can see in this set A, B, C, D elements are there. Set B, D, C, B, A elements are there. All the elements of A are present in B also. Order may not be the same. So A equals to B. Next, A is 4, 8, 12, 16 and B is 8, 4, 16, 18. In this set, A is equals to 4, 8, 12, 16 and B equals to 8, 4, 16, 18. See, in this 12 is there, 12 is not present here. And 18 is here and 18 is not present here. So, these two sets are not equal. Next one, 2, 4, 6, 8, 12, 10. B equals to x such that x is a positive even integer and x is less than or equal to 10. You can write this B in roster form. All the even positive integers 2, 4, 6, 8 and 10. 10 is included. These are the sets. Clearly A equals to all the elements present in A are also present in B. So A equals to B. Next one. X is a multiple of 10. B is 10, 15, 20, 25, 30. What is A in roster form? Multiple of 10 means 10, 20, 30 and goes on like that. And B is 10, 15, 20, 25 and 30. It's a multiple of 5 in fact. So 15 is not there, 25 is not there. So some elements are not there. All the elements of A are not present in E. So A is not equal to B. We'll move to the next question. Next question is, are the following pair of sets equal? Give reasons. A is 2, 3 and B is x such that x is the solution of x square plus 5x plus 6 equals to 0. First factorize them and find out the solution for x in the B. X square plus 5x plus 6 is equal to x plus 3 and x plus 2. Right? Factorizing, you will get this equals to 0. That means x equals to minus 3, x equals to minus 2. The solution set is, so B is minus 3, minus 2. A is 2, 3. So clearly A is not equal to B. Next question. A equals to x such that x is a letter in the word follow. That means A equals to F, O, L. Repeating letter we don't write. O also will not write. And O, W. This is the set A. In the word wolf, what is Y? In the word wolf, B is such that Y is a letter in the word wolf. W, O, L, F. So clearly all the elements of A are present in B. This is B. So clearly A equals to B. We'll move to the last question. From the sets given below, select equal sets. See, set A is 2, 4, 8, 12. We'll observe with all other sets. B is having 1, 2, 3, 4 as elements. So A is not equal to B. Next C. C is 4, 8, 12, 14. 2 is not here. Clearly A is not equal to C. Similarly, A is not equal to D. And A is not equal to E, F, G, H. So we'll move to B. 1, 2, 3, 4. Any elements are there? 1, 2, 3, 4. B is 1, 2, 3, 4 and D is 3, 1, 4, 2. All the elements of B are present in 3, 1, 4, 2 also. Order is different. but all the elements are present. So B equals to D. Compare other sets with B. E, F, G, H. No elements are common with that. Now see, 4, 8, 12, 14. 4, 8, 12, 14. You can compare 3, 1, 4, 2. No other set is equal to C. The elements present in C are not present in all other sets. So C is not equal to any other set here. D is O. D is 3, 1, 4, 2. No other sets D, F, G, H are not present in the are not equal to D. Let us see E. Minus 1, 1. Minus 1, 1. Yes. E equals to that minus 1 and 1 is present in G. Order is different, but the elements are same. E equals to G. Next F. F0 is A. 0A not present in any other set. G 1 minus 1 are present in H. So these are the only sets which are equal. Hope you understood all the questions and the concepts and the explanation to solutions. Before solving this exercise 1.2, don't forget to watch Introduction to Exercise 1.2. That concludes our video. We'll meet you in the next video. See you then.